Now let's talk about the distributed file system that Windows Server 2008 offers. The larger the enterprise, the more file servers the network users are likely to need. There are a number of reasons why network administrators might prefer to install multiple smaller servers rather than one large server, including the desire to improve network performance and reduce the internet work bandwidth by keeping traffic local, and the need to provide users at remote sites with local access to their files. The administration convenience of giving the individual departments or workgroups control over their own server is another reason for doing this, and also the ability to provide fault tolerance by using redundant servers. Generally speaking, deploying multiple servers provide a number of benefits. But when discussing file servers in particular, large enterprise network deployments present administrators with several problems that smaller deployments do not. First of all, using a large number of file servers often makes it difficult for users to locate their files. When administrators distribute shared folders among many servers, network users might need or might be forced to browse through multiple domains, servers, and shares to find the files they need. For experienced users that understand something of how network operates, this can be an exasperating inconvenience. But for inexperienced users who are totally unfamiliar with basic networking principles that usually is our day-to-day basics on a company, this exercise can be a mystified frustration for them. A second common problem for enterprise networks that have network at multiple sites is providing users with access to their files while minimizing the traffic passing over the expensive WAN connections. One option for administrator is to store files at a central location and let the remote users access them over the WAN. However, these solutions allow WAN traffic level to increase without check, and if a WAN connection should fail, then the remote users are cut off from their files. The other alternative is to maintain local copies of all of the files needed at each location. This provides users at every site with local access to their data, minimize WAN traffic, and enables the network to tolerate a WAN link failure with a minimal loss of productivity. However, to make this solution something, how do we call it? Something productive, it is necessary to synchronize the copies of the file at the different locations, so the changes made at one site are propagated to all of the others. An additional problem, and maybe this is the final I'm going to be talking about, for enterprise administrator is implementing a backup solution for small branch offices that do not have their own IT staff. Even if the organization is willing to install a complete backup hardware and software solution at each site, the task of changing the media, running the backup jobs, monitoring the progress, and performing any restores that they are needed will be left to untrained personnel. The alternative of backing up over the WAN connection to a centrally located backup server is likely to be slow, cost a lot, and the bandwidth is intensive. The DFS, or the distributed file system implemented in the Windows Server 2008 File Services role, includes two technologies: the DFS namespace and the DFS replication. These two address all of these problems and enables administrators to do the following: simplify the process of locating files, control the amount of traffic passing over one links, provide users at remote sites with local file server access, configure the network to survive a one-link failure, and facilitate consistent backups. Each of the two role services that make up the DFS role provides a service that can work together with the other to provide a DFS solution that is scalable to almost any size network. The DFS namespace role service provides a basic virtual directory functionality, and the DFS replication role service enables the administrator to deploy that virtual directory on multiple servers all over the enterprise. At its simplest, DFS is a virtual namespace technology that enables you to create a single directory tree that contains reference to shared folders located on various file servers. These servers are all over the network. This directory tree is virtual. It does not exist as a true copy of the folders on different servers. It is instead a collection of reference to the original folders, which user can browse as though it was an actual server share, so if it was in just one single location. The actual shared folders are referred to as the targets of the virtual folders in the namespace. Let's give an example of a network showing 3 file servers, each with its own shared folder. Normally, a user looking out for a particular file will have to share the folder on each server individually. By creating a DFS namespace that contains a virtual representation of the shared folders on all of the 3 servers, the user can share through a single directory structure. When the user attempts to open a file in the DFS namespace, that is the namespace server, the server is responsible for maintaining the list of the DFS shared folders and responding to user requests for those folders, forward the access request to the file server where the file is actually stored, which then supplies it to the user. Creating a DFS namespace enables users to locate their files more easily. Doesn't matter of where they are actually located. You can create multiple namespaces on a single server, and also create additional namespace servers for a single namespace. Mention this, we can tell that the DFS namespace uses 2 types of implementation, the domain-based and the standalone. The domain-based namespace is stored on one or more servers as part of an ADDS environment. Because of the integration with ADDS, this namespace provides increase in the scalability and availability because it can spread across multiple servers. On the standalone, this namespace is stored on a single server, so that it's restricted to the namespace or the space and the availability of the server on which it is stored. The standalone namespace server can use increased availability if they are hosted on a failover cluster. Also, the domain-based namespaces can be implemented in the following 2 models depending on the resources being used: the Windows Server 2008 mode and the Windows Server 2000 mode. In the Windows Server 2008 mode requires a domain to be running in Windows Server 2008 ADDS functional mode, and all namespaces servers are running or should be running the Windows Server 2008. This mode allows for access-based enumeration, ABE. With ABE enabled, users do not have access to or cannot view the files or folders to which they do not have access. Without ABE, you can allow users to see a file or folder but deny access when they attempt to access. The Windows Server 2000 mode on the other hand, requires a domain to be running in the Windows 2000 Mix ADDS functional mode or higher, and all of the namespace servers are running at least Windows Server 2000 server. This mode allows the use of multiple namespace servers and support the use of DFS replication to target folders.